So this is a series on systems of equations, and we're going to first define what it means to be a system and what it means to solve that system. So what is a system of equations? A system of equations is a set of equations with the same variable. And when we're solving that system of equations, that means that we are finding one or more solution that makes each equation in that system true. So we'll talk a little bit more about what that means. Here we're talking about a scatter plot of different times in a specific race. The x-axis is hours, and both of these equations are going to involve time in hours. And we're also talking about the miles from Fairbanks, Alaska, which is a city in Alaska. And notice that the dots are going down. If we were to continue that, we could estimate an equation for that it would continue going in that pattern. And in the triangles, it would probably start at 0 and it would increase something like that. Let me draw a little straighter line. And at a certain point, these two racers are in the same place at the same time. So for this equation and for this equation, this spot on this graph represents the point at which the racers are at the same place at the same time. And it looks to be approximately 90 hours and approximately 475 minutes. So at 90 hours of race time, they are 475 miles from Fairbanks. So we're going to look at these more generic graphs, and I want you to take a couple of notices. We'll do the first two together, and we're going to make the second two a thought experiment. So depending on the time of year in spring, the temperature is going to start changing. So in San Francisco, the time of year in spring, the temperature actually increases. But in Rio de Janeiro, as spring keeps going, the temperature decreases over time. And there's a specific, we're defining what this spot right here means. This spot right here means that the same time of spring has the same temperature in Rio de Janeiro and in San Francisco. So it's the time in which the temperature is the same in that part of spring. If we're looking at the number of tortillas manufactured and the cost to produce them, if we're making handmade tortillas, if I make more tortillas, the cost per tortilla is the same. But if I invest in a machine at the start, it costs more to make per tortilla. But as I make more and more and more, if I make machine-made tortillas, they become less and less expensive. But this intersection point means that at a certain number of tortillas, the cost to produce handmade and machine-made is exactly the same. I want you to take a moment to experiment. What does this intersection mean in this graph? And what does this intersection mean in this graph?